There are a number of options for setting up your own pre-compliance tests. Near-field probes like these are a great tool for inexpensive visualization and debugging of radiated pre-compliance measurements. A complete chamber, antenna, and a calibrated setup can match radiated compliance testing in a lab, but that all comes at a cost. Let's look today at one way to improve the reproducibility of near-field measurements for radiated and immunity testing. A TEM cell, or transverse electromagnetic cell, has some properties that make it quite useful for pre-compliance testing of small electronic devices. TEM cell consists of the septum, which is this conductive element here in the middle. It's designed to present a 50 ohm strip line. The walls, of course, grounded. The design of this cell suppresses some of the higher order resonance that helps extend its frequency. Ultimately, the cell's frequency range is limited by its size. And here we're using an open cell configuration. As you can see, there's no walls on the outsides. So that obviously isn't shielded. That being said, it provides a better approximation of field strength than the wand-style probes and makes it much easier to test for repeatability and gauge design improvements over time. Typically, we put our device here on the bottom, like this device we'll be testing today. As an affordable alternative to a complete compliance setup, we'll be demonstrating different test capabilities of the RSA 3000 real-time spectrum analyzer using the EMI measurement application. We're using this TBTC2 TEM cell from TechBox. You can purchase TEM cells like this from one of our many partners, including T Equipment in the United States and Electrometers in Canada. The main configuration here is for radiated emissions testing. We connect the spectrum analyzer to port 1 on the TEM cell using an inline DC block, this one here. On port 2, we have a 50 ohm terminator. In this setup, we put the device under test in the center of the cell, just above the bottom wall. It's estimated as a rule of thumb that spurious events with amplitudes higher than about 40 dB microvolts are problem areas in a TEM cell like this. In order to minimize background radiation, we can separate both the user from the TEM cell and the other equipment. The EMI measurement application runs right on the instrument. In tests like this, we often use the instrument's HDMI output and mouse compatibility, in addition to the touchscreen, depending on the exact use case. In the following videos, we'll go through each step in radiated emission pre-compliance testing using this test setup and demonstrating the capabilities of the EMI measurement application for the RSA series spectrum analyzers.